Hello everybody, this is the last video on the review assignment. I'm going to be looking at numbers 16 through 20 in this video. So go ahead and fast forward to whichever problem you need to see. In number 16, we have a 16 ounce package of pasta, which costs $1.20. And then we have a 48 ounce package of the same pasta, same brand, same everything, that costs $3.80. Which is the better buy? Why? All right, so what I would do is start out by writing some ratios that show the um, the unit costs. We have $1.20 here for 16 ounces for a 16 ounce package. Over here we have $3.80 for a 48 ounce package. I want to compare these to see which is the better buy. Now, I cannot put an equal sign between these because I don't know that they are equivalent. If they end up being the same price per ounce, I could say they're equal, um, but they probably aren't the same, or they're probably not equivalent ratios. So to tell which is the better value, the first thing I would do, you could, if you wanted to, take the price, divide by the number of ounces. I can take $1.20 and divide by 16. And find out what the price is for 1 ounce. And then I could take $3.80 and divide by 48 to figure out what the price is per ounce here. In fact, I'll do that. You may use calculators. So I'm taking $1.20 divided by 16. This comes out to 0.075 per ounce. What that means, since this is money, is if you move over 2 spaces, you'd get 7.5 cents per ounce. It's 7.5 cents per ounce. If I do that on the other one and take 380 and divide by 48, because you get 48 ounces there, that comes out to 0.07916, the 6 repeats, per ounce. Again, money is only supposed to go like 2 places past the decimal point. So this would be about 7.9 cents per ounce. 7.5 cents per ounce is a little cheaper. So this one's the better buy, $1.20 for 16 ounces. Now, there's an easier way to do this one. And when you're shopping for food, especially, and you see different packages and the different sized packages, a lot of times they are compatible. 16 ounces is actually 1 pound. 48 ounces is actually 3 pounds. If you take 16 times 3, it equals 48. So you could buy 3 of these smaller packages and you'd get the same amount of pasta, 48 ounces, that you get in a bigger package. So let's take $1.20 times 3 and just figure out what would it cost if you bought 3 of the smaller package instead of buying just 1 of the larger package. Well, $1.20 times 3 is $3.60. Well, $3.60, that's less than $3.80. We'd be better off buying 3 of these smaller packages. We'd spend 20 less cents for those 48 ounces of pasta. So which of these is the better buy? Well, it's the 16 ounce package for $1.20. So I know it's not this one or this one because those both are saying it's the 48 ounce package. It has to be one of these, so it's going to come down to my reason. The 16 ounce package, because if you bought 3 of them, you would have 48 ounces for $3.60. That's true. I like that one. The last one, the 16 ounce package, well, that's true. That is the one that's the better buy because smaller packages always cost less money. Well, it's less money, but you're getting less pasta. So that's not a good answer. Okay. It's the 16 ounce package because if you bought 3 of them, you would have 48 ounces for $3.60 instead of paying $3.80. Okay. All right, number 17, Maurice and Sylvia were competing to see who could do push-ups faster. Maurice did 45 push-ups in 15 seconds. I'm going to write that down. Maurice, 45 push-ups in 15 seconds. I'm going to write that as a ratio. Sylvia, there's Sylvia right there, did 62 push-ups in 20 seconds. Sylvia said she won. Is she correct? Why or why not? Now remember, the winner is the one that does more push-ups per second, right? The one that's going faster, because they're competing to see who can go faster. So what you can do is actually divide these to find the unit rate. If you divide 45 by 15, you're going to find out how many push-ups Maurice does per second. And 15 and 45 are compatible. You get 3 push-ups in 1 second. That's fast. Maurice does 3 push-ups per second. Now, if we do the same thing for Sylvia, 62 divided by 20 doesn't divide quite as nicely, but you can use a calculator, and it ends up being 3.1 push-ups in 1 second. Uh-oh. That means Sylvia is a little bit faster. She does 3.1 push-ups per second. Maurice does 3 push-ups per second. So Sylvia's faster. Back to the question. Sylvia said she won. Is she correct? Yeah, she won. So the answer has to be yes. So I know it's not no. I can rule these two out. Now it's down to the reasons. Sylvia did 17 more push-ups than Maurice in the same amount of time. No, Sylvia did 17 more push-ups, but it was a different amount of time. Okay, so that's no good. Yes, Sylvia did 3.1 push-ups per second. Maurice only did 3 push-ups per second. That's true. So that's my answer there for number 17. All right, number 18. Which is the slowest rate below? We have 3 laps in 5 minutes, 2 laps in 3 minutes. These are all showing laps per minute. Have you noticed how when you have time measurements, the time is always in the bottom of your ratio? We have laps per minute here. If you want to compare these, you can divide the laps by the minute. You can see in the ratio, the fraction bar always means divide. So we can divide 3 by 5. 3 divided by 5, and you can use a calculator for this, equals 0.6. So that's 6/10 of a lap per minute. If you divide 2 by 3, you're going to get 0.6 repeating laps per minute. If you divide 3 by 4, that equals 0.75 laps per minute. If you divide 4 by 5, you get 0.8 laps per minute. So which is the slowest rate? Well, it's the one that would be the smallest, the fewest number of laps per minute. And that would be 0.6. 0.6 is a little, see, 0.6 is really 0.6000. You can keep adding zeros forever. This one is 0.6666. So yeah, this one is the slowest, 3 laps in 5 minutes. Okay, and again, just take your laps per minute, divide the laps by the minutes, and figure out how many laps they are each running in 1 minute's time. These two are pretty close, but 3 laps in 5 minutes is a little bit slower. That's the slowest rate. Number 19, a plane travels at a rate of 780 miles in 2 hours. I'm going to write that as a rate. 780 miles in 2 hours. We always talk about speed in miles per hour, right? At this rate, how far will it travel in 3.5 hours? Again, notice I'm putting the time in the bottom and the distance in miles. How far will it travel in 3.5 hours? I don't know what this distance is. I could put a D there for distance. I'm just going to put a question mark there. Are 2 and 3.5 compatible? If it were asking like 4 hours, then I'd just have to multiply by 2, wouldn't I? But 3.5 is not compatible with 2. So what I'm going to do instead is take the 780 miles in 2 hours, and I'm going to find the unit rate by dividing them both by 2. Take 780 divided by 2, and you get 390 miles in 1 hour. That plane is traveling 390 miles per hour. Okay? So if I want to find the rate for 3.5 hours, then I have to multiply by 3.5. So I will do that to this as well, multiply by 3.5. And we get to use a calculator. So we'll take 390 times 3.5. And I need to move and turn my light on, otherwise my calculator won't work. Ooh. There we go. Sorry about that. So now I'm going to try it. 390 times 3.5. And that equals 1,365 miles in 3.5 hours. So that's option B right here, 1,365 miles in 3.5 hours. One more problem, number 20. A pickup truck travels 150 miles on 12 gallons of gas. I'm going to write that as a ratio here, 150 miles on 12 gallons of gas. We always talk about miles per gallon when we're talking about fuel efficiency. Miles per gallon. Miles comes first, the distance. Gallons comes second, the capacity. Okay? How many gallons will it need to travel 375 miles? I'm going to write a proportion here. 150 miles uses 12 gallons. 375 miles, I'm again putting miles in the top. I have to stay consistent. Would be how many gallons? Let's call it G for gallons. Okay. Well, to solve this, are 150 and 375 compatible? Not really. I mean, you could take it times 2.5, but you might not recognize that looking at it. So instead, take this right here, divide to find the unit cost. Find out, well, not the unit cost, the unit rate. So we divide 150 by 12. And so I'm going to go ahead and do that, 150 divided by 12. And I can use my calculator, but it's, yeah, I'll use my calculator. 150 divided by 12 equals 12.5. So 12.5 miles in 1 gallon of gas. Pickup trucks don't get very good gas mileage. 12.5 miles per gallon, that's pretty lousy. Okay? So if we're going to go 375 miles, okay, then I'm going to have to take that 375 and divide by 12.5. And I get 30. So that means it's going to be 30 gallons of gas. Okay. Could I have done this one another way? Absolutely, yes. I certainly could have. Okay. And I'll show you that here quickly. All right, if it's 150 miles using 12 gallons of gas, I'm putting miles in the top, gallons in the bottom of my ratio. Then 375 miles, that goes in the top, would be how many gallons? I honestly think it would be easier to take 375 and divide by 150. Okay, and that equals 2.5. So the inverse of that would be, well, 150 times 2.5 equals 375. So we could take 12 times 2.5 to find the number of gallons. And guess what? If you take 12 times 2.5, you can check this on a calculator. That equals 30 gallons of gas. Okay, so that truck would need 30 gallons of gas to go 375 miles. All right, that's it. Be sure to study. Good luck on your test tomorrow.